Kia ora Year 12. In this video I'm going to do a mix-up of old exam problems that have surds and fractional powers in them somewhere. So this video is a little bit different because I'm not just focusing on one particular skill in one context, so I'm going to do quite a lot of different questions. So some of them will be ones where we have to factorise, and some of them we're going to have to solve. Sometimes we'll have to simplify, and sometimes we'll have to rearrange. And I'm doing it like this for students who've already got the basics down of fractional powers and surds, but just get a little bit confused when they pop up in different settings. So these questions are quite hard for lots of students, and heaps of practice first at individual skills will help. This video is going to go from 2022 back towards 2018, and I'll just get as far as I get in 15 minutes and then do another one later on tonight. Okay, so starting with last year's paper, we had a factorised one where we had to factorise completely this expression here, which has got a surd in it. So this looks a bit different from what you saw in year 9 and 10 because we used to do things like this, like we might have had a 6x cubed y minus 15x squared y to the power of 3. The only difference here is that we've got this surd in it. So when I look at this, what I do is I work systematically through the numbers and then each variable, and I take out the highest common factor. And then I figure out how to times that back. So the highest common factor in the numbers is going to be 3. The highest common factor in the x's will be x squared. Now, when I look at the y's, the way I think about this is I've got y here and I've got the square root of y here. So the highest common factor in there to me is going to be root y. I'm going to show you a second way that you could have done this in a few minutes. But now I've looked at each of those things and I just have to work out what do I multiply by to get back to what I want. So 3 watts give me 6. 3 2's will give me 6. I want to end up with x cubed, but I've got x squared, so I need to times by another x. Now looking at the y, we've taken out a highest common factor of the square root of y, so we need to times it by another square root of y in here. Now we move on to the next term. So 3 watts will give me 15. 3 5's will give me 15. Look at the x squared. I've already got x squared, so that's matching up already. And I've already got root y here. So I don't need anything else. So we're done. Okay. Now the best thing to do once you've done a problem like that, which is a slightly mucky factorising one, is just to expand it to yourself and check that it all works. So doing that really quickly down here, I get 6 x cubed times y minus 15x squared. Okay, so I'm just going to erase that because I don't want anyone getting confused by that. So we've done our factorising. Now, the other way that you could do this, which is slightly odd, but it kind of still works, is that instead of putting root y here, we could instead have gone equals 3x squared, and then I could have decided to make the whole y my common factor, and that would give me inside here 2x, and then I'd want to divide through, sorry, no, that's right, 2x minus 5, and then I'd have x squared matching up here, but I'd have too much y here, so I need to divide out by that. So you could do it that way. The schedule had that as an alternative answer. I think that's an unusual way to think about it. It's not wrong. Both of these are a little bit odd because there's no one rule for factorising once you're working with surds. I prefer the first one, so I'm going to delete this off here. Okay, that was a merit question, not surprisingly, because it was just a little bit strange. Okay, moving on to the second question with surds in last year's paper. This was also a merit question. We're given a little surd equation to solve. And unfortunately, the schedule has got what I think is a mistake in it. So the first thing to say in here is that whenever you're solving an equation with surds, you need to be really careful at the end. You have to make sure that you haven't accidentally got a solution that really isn't a solution. So when you get to the end of a surd equation, always grab your calculator and just check that the answers work. And in this case, you'll find that one of them doesn't work. So we've got the square root of 2x plus 3 is equal to 3x. Yuck. I can't do much with that. But what I can do is I can square both sides. So if I square a square root, I'll get something nice and easy, and I have to do the same to both sides of the equation. So squaring the square root gets me back to just 2x plus 3 on the left-hand side. And when I square 3x, I get 9x squared. You can see now that we're working with a quadratic. So we've got 0 is equal to 9x squared minus 2x minus 3. So let's have a quick look at that. Or you could chuck that into your calculator and have a look at it. If I try to do grouping on it, I want two numbers that times together to give me negative 27, and I want two numbers that add to give me negative 2. In other words, two numbers with a gap of 2 and a product of 27. Now, there aren't two nice factors that do that, because 1 and 27 doesn't do that, and 9 and 3 doesn't do that. So we're kind of stuck. We have to use the quadratic formula, or you could do it on your calculator, I think, and get away with it. But we'll do some quadratic formula practice here. And those of you who are in my class know that sometimes I do completing the square to solve equations, but I'm not going to do that here because I've got yucky coefficients happening. So I'm just going to go straight to the quadratic formula. X is equal to negative b plus or minus this. And that gives me x is equal to negative 2. So 2 plus or minus the square root of negative 2 squared. So 4 minus 4 times 9 times negative 3 divided by 18. That gives me 2 plus or minus the square root of 112 divided by 18. Now, you could get a nice answer for that, and the nice answer for that would be this. It would be 1/9 plus or minus 2/9 root 7. And there'd be times in the level 2 algebra paper where you had to use those kinds of ideas. But in this question, we really don't care. All we're asked to do is to solve the equation. So that gives me two solutions, and I'm going to now get them as decimal approximations. So I've just gone to 4dp with that one, and I've gone to 4dp with this one. And that's as far as the schedule goes, and it says, okay, you get a merit tick for that. Now, there's a problem with that, though, because when we go back to our original equation, we had this thing here. And you can probably already see, if you're watching this video, what the problem is going to be. When I take the square root of a number, it's always positive. But when I take 3 times this number, it's going to be negative. So where we're going to end up is that this solution is going to be okay, but that this one's going to be bad. But we have to show that. Right, so now we're just going to put down a little note that we're checking, and we're going to go like this. 2 times 0.6991 plus 3 gives me 2.0972, which is equal to 3 times 0.6991. So it's valid. Now let's do the same thing with my other one. 2 times negative 0.4768 plus 3 gives me, did I write down what number it was? I don't think I did. I get a positive number, so that's not the problem. But that is not equal to 3 times negative 0.4768, which was, it was negative 1.4 something. So x is equal to negative 0.4768 is not a solution. But x is equal to 0.6991 is the only solution. So I think that that's quite a lot of understanding to show for level 2, and that last step of looking at the two of them might take that to extended abstract or excellence level thinking. Anyway, but in last year's paper, you were just given merit if you just turned this, squared both sides, got it to a quadratic, and then solved it. And if you got those two solutions, you got a merit mark. But what I'm telling you is that actually you always have to check when you've got a surd equation, go back and have a look at those solutions. Okay, well, I'm up to 9 minutes already, and I'm only just through 2022, but they get a bit easier from here. So question 3 was one where we just had to simplify fully this expression. Right, okay, so the square root of 49 times y to the power of 36 is one that we should be able to do just by looking, and we get 7 for the square root of 49, and then we get y to the power of 18. Okay, it's not y to the power of 6, which is what some junior students tend to think. And if you want to check that you've got that right, just square it back and see what happens. So when you go 7y to the 18 squared, you get 49, and then when we multiply these powers, you get y to the 36. And it's because of that property of multiplying the powers that you have to be really careful when you're coming to questions like this one here. Okay, so it's quite common to make mistakes with those, so that's one place where doing a bit of practice will really help you get the hang of those. And then you can see another one coming up in 2021. Right, that is, I think that was just, yeah, that was just a little achieved question. Right, next up, 2021, question 1a. This one here had a simplifying thing. I left out the other one because it didn't have any fractional powers. Let's have a look. So when we've got the cube root of 8y to the 27, we can do this in a few different ways. For me, when I look at the little 3 here in the 8, I straight away think that the cube root of 8 is 2. And then the cube root of 27 is going to be not what I want, right? So this is the place that people go wrong. We're cube rooting the 8, but what we're really doing with this question is the following. We're doing 8y to the 27 to the power of 1/3. So the 8 to the power of 1/3 is where I get the 2, right? The cube root of 8. But then here, I'm not doing the cube root of 27. So I'm not doing y to the power of 3. I'm doing y to the power of 27 times 1/3. So my answer here is 2y to the power of 9. So hopefully you can see the similarity between this question and the one we just did up here, where we had the square root and we had y to the power of 36. Ends up giving me blah blah y to the 18. Here we've got the cube root and the y to the 27, so we end up with 2y to the power of 9. And again, the best way to check you haven't mucked those up is just to quickly go backwards and cube the whole thing and see that you get back to the answer. All right, I think I've just got time to do this last one, which is a little bit harder. This is a merit question. I quite like it. I think it's a little bit different. So we've got a function, and the function takes a value of x, and then it does something to it, and out pops w. We have to rearrange it and make x the subject of the formula. So we start off with w is equal to x plus 2 to the power of 2/5. To undo this, we're going to do w to the power of 5/2 on both sides. Let's just fix that up. So w to the power of 5/2. Let's just think about why that works. Well, it works because I'm doing all of this to the power of 5/2, and that's how I can get this back to the power of 1. So that leaves me with w to the 5/2 is equal to x plus 2. I think that's the hardest step in this problem. Okay. The next thing to do, remember we're trying to make x the subject instead of w. So w to the power of 5/2 minus 2 is equal to x. Now actually that's only an achieved question, right? Because there's not really much difficult stuff in there as long as you're good with this undoing that, and that comes from a level 1 idea. Right, kind of a level 1 idea. Anyway, so that's my first thing there. Now the last part that I'm going to do very quickly is for what values of x will the function have values less than 20? Note here we're told that x is a whole number. So all I'm going to do here is to solve this. I want to know for what values of x will w be less than 20. So you can think of the first part as a warm-up for this. I'm going to do to the power of 5/2 on both sides. So don't have to worry about changing the sign because I haven't divided by negative or times by negative. So we've got this, and now what do I have? I have x is less than 20 to the power of 5/2, take away 2. And that gets me x is less than 1786.85. But remember that x is a whole number. So we're going to have x is less than or equal to 1786. And you can check that. You can do 1786 plus 2 is 1788. And then when you do 1788 to the power of 2/5 or 0.4, you get something very close to 20. You get 19 point blah, blah, blah. Okay, that was a very long video. If you're still watching, the first person who watches right through to here gets a small chocolate bar You can come and claim it from me next term. I'll try and remember to go to the supermarket and buy some. Thanks for watching. Email me if there are any other topics that you'd like done in this format.